Okay, so I wanted to give you an illustration on how to use the normal curve that's in the appendix of your textbook. So let's say, for example, we had a z-value that is equal to 1.0. So if you went to this table, all your z-scores, z-values on the left margin or the top row. Everything in the body of this table is your areas or probabilities. So the idea is, the way this table works is if I were to draw my curve, this table would give you, if you find a z-value that's 1.0, you start in the middle at 0, and 1 would be right there. So basically, the area that your table is going to give you is the area that goes from 0 up to 1. So it essentially is looking at half of the curve. So if I were to find 1.0, which is right there, the area that's right next to it is 0.3413. That would be the area from basically 0 z-score up to 1, all right? So the idea is the probabilities that they give you is always going to be to the left of your z-value. And so if we wanted to go from 0 to 1, the area would be 0.3413. And then, of course, obviously, if we ever had to go down to a negative 1, because of the symmetrical nature of the curve, 0 to 1 and 0 to negative 1 is exactly the same area. So that would also have an area that's 0.3413. And perhaps you came across the normal curve in the book where they talked about if you had a z-score that's plus or minus 1, and they said that's approximately 68.26% of all data. Well, if you were to add 0.3413 plus 0.3413, guys, that would give you 0.6826, okay? Now, let me give you one more illustration on this. So let's say we had a z-value that was equal to 1.96. And let's say I wanted to find the area to the left of that. So if I were to draw my curve, obviously 0 is in the middle, 1.96 would be right there. I'm going to draw my line. The area that the table, again, the area that the table gives you is 0 all the way up to 1.96. So for example, if I went down to find 1.9, where that intersects with 1.96 is 0.475. So that area right there would be 0.475. But if I wanted everything that extends to the rest of the curve, obviously we know that the rest of the curve is 0.5. You just simply take 0.5 plus 0.475 and you'd get 0.975. So you could basically say that the probability of the area that's to the left of 1.96 would be equal to 0.975. So again, just wanted to show you a couple little things about how to use this table. If you get stuck and you can't follow the examples in the book, or you have some questions, please email me or give me a call. Let me know. I'll be glad to help.